Hi everyone, my name is Carlota. I'm one of the team members of Barcelona from Sensing Barcelona. And I'm going to explain a little bit of our biosensor. So this year we have an immunochronography as a for the quantification adalimumab. We designed a unique strip and a lateral flow reader. Our strip is a lateral flow, and yeah. Okay, we have designed a strip that if 3 lines come red out, the test comes invalid. And if only have 2 lines, the test is valid. So why we choose a lateral flow? So because they don't need pretreatment. Low sample volume is requirement because as a lateral flow, the sample comes across the membrane. Long-term preservation, and it isn't expensive. So as a usual lateral flow, we put the sample in the sample pad, and the sample comes to the membrane, and the first line that they find is T1. The T1 is antibodies of adalimumab without the AFC region of the antibody, and it's for detect an immunogenic response against the treatment. The second line, T2, is in the line was printed with 10F alpha, 10EF, and is for detect the adalimumab. And our third line is the control line, just for ensure that the test is nicely working. And yeah, the rest of the samples comes to the absorbent pad. So I want to explain a little bit how the strip works. So as I say, T1 detects immunogenic response towards the treatment. So what we do was, with pepsin and endopeptidase, break the monoclonal antibody of adalimumab, and with a filter we remove the variable part, FIB. So when the sample, and we print it in the first line, the T1. So when the free adalimumab, the sample comes to the membrane, if anti-adalimumab antibodies are free in the sample, this line detects. So this is the anti-adalimumab antibody. As I reported, we use colloidal gold and protein A, sorry. And yeah, with that technique, the thing is the qualified and not quantitative, we detect that the treatment is not working for that patient. So after put the strip into the lecture, we know something wrong is happened. Our second line allows to detect adalimumab. It's for adalimumab quantification. So we print the cytokine 10EF. When the sample comes to the membrane, free adalimumab in the sample binds to it. And also we, as a reporter, use colloidal gold plus protein A. And our last line is the control line, and we just put adalimumab antibody, and the rest of the excess of the colloidal gold in the sample binds to it. So for the reader, the lateral flow reader, we use a Raspberry Pi and a Raspberry Pi camera for take a photo for the strip. And for the processing part, we use a Python and ImageG. That is analysis from Java. And yeah, we know this is a simple technology, but it works very nicely. We have an accuracy from 0.95. And for take the picture for have a good picture, we create inside the lecture nicely light environment for have nice pictures, and yeah. And also it's very cheap. It's very affordable lecture from everyone. If a passion will be to have in your house, they have it because it's not too much expensive and it's small. And yeah, that's all.
So, first question. Does somebody have a question? Yeah?
You are using strips and paper technology, which is also known as a very cheap method, which is a real big advantage. But one of the issues might be the accuracy and the precision with the results. Do you also from your results, it's looking into the direction that to be able to decide whether it's 2 or 3 is still difficult. Do you expect that with this technology improvements can be made to make it more accurate?
Probably yes, because when we were working in the strip, we tried with different size of the pores of the membrane, because we know that if the membrane the pores of the membrane is very bigger, we lost a lot of antibodies. So in the future we want to try with another kind of membrane. But we don't think, maybe with the lecture we have very high accuracy, but probably we can do more things with the lecture and the strip, because this immunogenic part can also be so nice with work with it, with have a result also, because now we don't have a measure for the immunogenic response. So probably for this part it's something that we can work.
Okay, thank you very much.
So how much time does it take to read your sample? So how much time does it take to the lateral flow assay to be performed and to read the sample afterwards?
Sorry?
How much time does it take for the lateral flow assay to take place? Because normally, if you take a pregnancy test, it will take 10, 15 minutes sometimes for the readout. So how much time does it take on your assay?
Now we are playing with different quantity of sample, and if we put a lot of sample, it takes a lot of time. But if the sample is less, we are in 10 minutes, 12.
And if you go back to the results slide you had, yes, this one. So when I look at the mean pixel value, there's not much difference between the very high to very low concentrations. Can you maybe explain a little bit more what you measure with the mean pixel value, and is there a way to extend the range of response?
I don't know. Sorry, but I can explain because I don't do this part. So yeah. Someone, Paula, you want to come explain?
Maybe in the meantime, I can ask you. Do you want to explain now?
No, it's fine. Yeah.
So you developed did you develop the assay yourself?
Yeah.
So it was
completely.
It's a total new assay you have developed.
Yeah.
And the readout and the camera, did you build that yourself, the custom made?
Yeah.
Yeah.
All the complete biosensor is made by us.
Okay.
Yeah. All the things that we have to, yes.
Okay.
Yeah. So concerning the pixel value. So.
Yeah. So the thing is, because when we do the strip, the white part of the strip is not really white until it dries 100%. So the mean values takes into consideration the white, not white because it's wet, part. So the difference, it's shorter. If we would leave the strip to dry maybe for half an hour, the contrast is bigger, so we would have more separate values.
Okay, so are you measuring just the red pixels for the gold particles? Or
So what we do is we apply, we separate the picture into 3 canals, RGB, and we get the green values because they are complementary to the red, and then we do enhance the contrast like by 5% more or less to measure the values.
Okay, so I'm not sure if I understand because so since you're measuring a reflectance, the particles will absorb green, so you'll see less green on your camera. I would expect to more use the red channel.
No. When we divide the into 3 channels, the red is the value you see the less because it creates less contrast.
Yeah, because there's less red light if you use, for example, a flash or something like that. But maybe you can talk about it later on.
Okay.
Okay.
So if I understand the way it works, so you load the sample contains adalimumab, potentially also anti-adalimumab antibodies developed by the body. They mix with the colloidal particles that display protein A correctly, and then these caravan starts moving towards through the assay.
Yeah.
Together with a little bit of adalimumab, plasma will also come with a very, very high concentration of our own IgG. So what is the chance that the colloidal particles with protein A will be depleted by the native IgG present in the plasma so that the adalimumab will find itself not bound by any protein A particle?
I suppose because we have a colloidal gold in excess. So for that we have the control line because we know that colloidal gold is in excess. So I think adalimumab always are going to bind with some of the nanoparticles of colloidal gold and protein A.
You have enough for all the antibodies, both adalimumab and the native antibodies. Gotcha. Thanks.
Yep. So I ask a question. Okay. So you use the Raspberry, you said, and the camera.
Yeah.
So, but you don't work with any optical filters or whatever whatsoever. So is this the best optical solution you can consider to read?
It's
color
not
signal?
like the original Raspberry camera.
Yeah.
It's from another producer, and we only use software filters. We don't use any physical filters. Yeah.
Okay. And do you really zoom on the area? So, or is this given by the construction of the?
It's given by the construction.
Okay.
Yeah.
Oh, okay.
So what we did to optimize the picture, it was to calculate the best distance where the camera was, best distance range where the camera worked, in order to take the best quality, because we didn't want to zoom, because when you zoom a picture you lose quality, you lose information in each pixel.
Yeah, but
So
the size of your box could be much smaller with a better optics,
No.
right?
No, because also we realized that we need a space, to leave space behind the strip, because if not, the focus, it wasn't as clear if we didn't leave 8 centimeters under the strip of space.
Okay.
If we put the background too close, it wasn't as good the result.
Okay. Okay. Good.
So the last question.
Very small question. I can imagine that because you use a droplet of whole blood, I guess. Is there any interference from things like hemolysis? So when, for example, red blood cells lyse, you get migration of colors through your strip as well. Do you know whether you find any interference with that?
When we start with the strip, we use serum bovine, so it works well.
Yeah.
And when we use plasma, we have more difficulties, but we don't try with real blood.
Okay. Okay.
So we
Okay.
don't know.
Okay.